Hello friends, welcome to the channel. Today we are here to discuss a new topic which is known as level measurement. In earlier discussions we studied about types of flow on the basis of Reynolds number, then we studied Bernoulli equation, and then we discussed rotameter, and now we are discussing about the level measurement, how level in a drum is maintained in a process industry. So let's start the topic. So we are controlling level in the drum. There must be some liquid or some fluid will be filled in the drum. So we have to maintain that fluid level in the process industry. Okay. So how we do this? So let's let's start with the diagram. This is your drum. Okay. The maximum height up to which we can fill the liquid is 2 meter. I am considering the maximum height up to which we can fill the liquid is 2 meter. Okay. The level in the drum will be sensed and it is transmitted through level transmitter. Okay. Here we will be having set point. Here we will be having set point. This will be the measured value. Okay. I am considering height in the tank is level of the tank as HMT. Height level of the tank at time t. Okay. And this level transmitter will convert this height into some measurable current. Okay. So the current which is corresponding to this height HM is IMT. Our set point is IST. Okay. Now this current will be compared with the set point and error will be generated. This is our error. Error will be going to the level controller LC. Okay. Now level controller will also generate some controller current ICT. This ICT will be depending on the error. How much error we are getting. Okay. This current will be going to I to P converter. I to P converter is nothing but it will convert this current into pressure. Okay. Now this pressure is applied to the pneumatic valve. Okay. This pressure is applied to this pneumatic valve, and this valve is for inflow in the tank. Okay. And this is outflow. This is outflow, this is inflow. Now we have to maintain the level in the tank. Okay. Now we have some relations of various physical parameters. Okay. To convert this height of the tank, level of the tank into this measurable current, let me write the ranges. Okay. The maximum height is 2 meter and the minimum is 0 meter. Yes or no? As I said, the maximum capacity or the maximum height up to which water can be filled in this tank is in this drum or in this tank is 2 meter. Okay. Now what is the range of IMT? IMT is standard industrial range, 4 to 20 milliampere. So this ICT is also 4 to 20 milliampere. Okay, and what this IP2 converter will give some pressure signal PT, and this PT range is 3 psi to 15 psi. Okay, so these are some ranges, these are some standard ranges derived for all these physical parameters. Now, how we can convert this height level into current? We can do this by this expression: height of the tank at time t minus minimum level 0 by maximum 2 minus minimum 0 equal to corresponding current IMT minus minimum value of IMT is 4 by maximum minus minimum 20 minus 4. So this will give IMT minus 4 by 16. So from here IMT is 8 milliampere into HMT plus 4 milliampere. Okay, simple algebraic expression, nothing rocket science. Okay, now if I convert IMT in terms of HMT in terms of IMT, then we will get HMT is nothing but 1 by 8 IMT, okay, minus 4 by 8. It will be in meters because unit of height is meter here. I have taken as meter. These two relations are very much important in today's video or today's lecture. Okay, now, so these are some classifications. Okay, and similarly there is a relation between this pressure PT and ICT. Okay, what is that relation? ICT minus minimum of ICT is 4 by 20 minus 4 is PT minus 3 by 15 minus 3. From here, if you get IT, you can calculate PT. What is PT? 12 by 16 into ICT minus 4 plus 3. Okay, so this is the relation between pressure PT and ICT. So these are some simple analysis. So now we will start the process. Okay, note it down till here. Okay, now someone enters into the control room, an engineer entered into the control room and decided that today's set point for this tank is 1 meter. He decided that we have to maintain the height of the liquid filled in this tank up to 1 meter. That means our set point in terms of height is 1 meter. I can consider it as HST. Okay, as for set point. Okay, in that way, what will be the set point in terms of current? Similar, HST minus minimum 0 by 2 minus 0 equal to IST minus 4 by 16. Okay, what is our set point? HST 1. From here IST is 12 milliampere. Okay, so if we talk about in terms of height, the set point is 1 meter, and if we talk about in terms of IST, it is 12 milliampere. Fine. Now the set point has been decided. Now we will start the process. Okay, these two equations are important, so I will not rub this. Now, what happened? At 10 a.m. set point has been decided. Okay, now at 10 a.m. we are starting the process. initially tank is empty, that means HMT is nothing but 0 meters. In that case, what will be the IMT? Put here HMT equal to 0, 8 into 0, 0 plus 4, 4 milliampere. Yes or no? Now what will happen? IMT is getting as IMT equal to 4 ampere. Now our set point is 12. That means our desired level is 12 milliampere, but we are getting only 4 milliampere. That means there must be some error. What is error? Set point minus measure point. Set point is 12 minus measured value 4. So here we will get error. 12 minus 4 equal to 8 milliampere. Now we got error as 8 milliampere. Now this error will go to the controller and controller will respond according to the error received. So what will be the ICT? How much current we required? This error. That means error is required. This is the only difference between set point and measured value. That means this value is required. So controller will send current value of 8 milliampere to I2P. Then I2P will convert this current into some pressure value by this okay, by this formula. Put ICT equal to 8 minus 4 by 4 4 by 16 4 to 12 3 6. Now from here PT equal to 6 psi. Fine. So as soon as process has been started, we got these values. Initially tank was empty, so the current we measured by with the help of level transmitter is 4 milliampere. Error generated, controller generated some error controller output, that is 8 milliampere. Then corresponding pressure has been generated. Then this pressure was applied to the valve, and as soon as pressure is applied, this valve is actuated. Now there will be some filling started. Okay, now this tank will start filling. Okay, there will be some filling. This valve is closed. Initially this valve is closed. It has different significance in the process. I will tell it at the later stage. Now this will start filling. What is your set point? Set point is this 1 meter. We have to maintain the level of the liquid in the tank up to 1 meter only, not beyond 1 meter, not less than 1 meter. Fine. Now we are analyzing situation after 5 seconds. Okay, we are analyzing situation after 5 seconds. Now I am considering after 5 seconds the height of the level of the tank is 0.25 meter. The level of the water in your tank is 0.25 meter. That means if I convert into corresponding current, what will be the IMT? Put here HM equal to 1 by 4, 2 plus 4, 6. Now the level transmitter will generate a current of 6 milliampere. Okay, again we will compare with set point and error will be generated. Error is set point minus measured. Set point is 12 minus 6 milliampere. So now again controller will generate some current controller output which will be corresponding to the error, which is also 6 milliampere. Okay, so what will be corresponding pressure at the valve, inlet valve? Put 6 here. 6 minus 4, 2 by 16, 1 by 8, 12 by 8 plus 3. Okay, 12 by 8 plus 3, that means 3 by 2, 4.5. Okay, yes or no? 4.5 milliampere. Now as soon as tank will start filling, then this valve will be slightly closed. Why? If it is continued to be open in as it was in this condition, then flow will it may happen that flow will go beyond, the level will go beyond 1 meter. Okay, so as soon as we are approaching towards 1 meter, this valve has to be closed also. Okay, if you are not closing this valve, this liquid level will go beyond 1 meter, and that is also not required. We only have to maintain this 1 meter only. Okay, so this is the condition. So you can observe here from here. What you can observe? See here. As error is decreasing, here error was 8 milliampere, here error is 6 milliampere. As error is decreasing, the controller output. Controller output is ICT. ICT is also decreasing. Yes or no? Here error was 8 milliampere, ICT was 8 milliampere. Here error is 6 milliampere, ICT is 6 milliampere. That means the controller output is directly proportional to the error generated. Yes or no? The controller output is directly proportional to the error generated. That means it is the work of proportional controller. Proportional controller. Yes or no? Because controller is acting directly proportional to the controller function. The function of controller is directly proportional to the error generated. That means controller output, that is ICT, is a function of error. Yes or no? So till now what we have observed is that the controller is acting according to the error signal generated. Yes or no? Note it down, then we will move further. Now we will draw the block diagram for this process. I hope this schematic diagram is clear to everyone. Now we will draw the block diagram. So if you have completed till now, let's move. Please pause the video and draw it. Okay. These three questions are very much important. Not this one. These two. Okay. Now let's see what will be the block diagram. Okay. Let's start from the set point. Here is your set point. Okay. I am talking in terms of current. What was set point? 12 milliampere. Okay. Error will be generated, ET. It will be given to the controller, and we are talking about proportional controller. Let it, I am considering its gain as Kp. Okay. Now controller output is ICT, again current, and this will be given to the actuator. Actuator. Yes or no? What was the output of actuator? Actuator was the output of actuator was that flow. You know, this was ICT, I2P, then QI. Yes or no? So the ultimate output was QIT. Yes or no? Now this will go to the process or plant. Okay. So what is the output of the plant? What we want to control? That is height of the level of the tank. Okay. Now level of the tank is measured and given to the transmitter. Yes or no? And transmitter is converted into current IMT. This is HMT. Okay, so this is actuator. I am taking its gain as A dash. So this is your whole process in terms of block diagram. Okay, fine. Okay, this is minus. Now I am taking block by block. This is your controller Kp. Its output is ICT and input is error. Yes or no? So from here, what will be the ICT? ICT will be Kp into Et. Yes or no? Fine. Now come to actuator. Gain of actuator is K dash. I am taking it as 1. Its input is ICT and its output is inflow. What is QIT? QIT is inflow. So from here, what is QIT? QIT equal to IC T. Yes or no? Fine. Now we will talk about process. Okay. Input of process is flow and output is what we are controlling, liquid level. Fine. Okay. When you do higher studies, you will get to know the liquid level process is nothing but a first order system. In liquid level process, to maintain a liquid level in a tank or in a boiler, it is simply a first order process. So what is the general equation of first order equation? First order system, A naught dy by dt plus A1 yt equal to B naught xt. Yes or no? This is the general equation for first order in time domain. Okay. Fine. So what is y? Y is output and x is input. So for this plant, what is output? Hm. I am considering constant as 1. So fine. Dy by dt plus yt equal to xt. Yes or no? Now, what is y here? What is output? hmt. So okay, put y equal to hmt. And what is xt? Xt is qit. Fine. Now keep this into a box. Now look here. I see it equal to kp into et. Okay. From these two equations, what is qit? Qit is kp into et. From these two equations. Now what is error signal et? Et is 12 minus imt. Yes or no? Et is set point minus measured value. So we can write qit as kp into 12 minus imt. Yes or no? Fine. What is hmt? Hmt is this one. That's why I kept it here. So you can put this. Fine. D by dt. What is hmt? 1 by 8 imt minus 4 by 8 plus what is hmt? Same, 1 by 8 imt minus 4 by 8 equal to what is qit? Qit is kp into 12 minus imt. Yes or no? Fine. Now I am erasing this part. Fine. Are you getting these points? Now I can write, I am taking this d by dt inside. So 1 by 8 d by dt of imt. I am taking 1 by 8 outside. Okay. Now remaining differentiation of constant is 0. So that means 0 plus 1 by 8 imt. I am taking this 4 by 8 to that side. So minus 4 by 8 while going right side it will become plus 4 by 8. I will multiply kp inside plus 12 kp minus kp into imt. Now take LCM of 8. 4. One more thing, keep this take this imt part to the right side, so you will get 1 plus kp, 1 plus 8 kp into imt equal to 4 4 plus 1296 kp. Okay, so this is the equation after arranging all the terms. Fine. Got it or not? I just took LCM as 8 and just arranged all the terms. Okay. So note it down. So this equation, are you familiar with this equation? It is simple. What is this equation? First order differential equation, yes or no? Now you know this, how to solve. You know the procedure to solve it. Okay, here IMT is dependent term and T is independent. Okay, so in that case we need to find integrating factor, which is equal to e to the power 1 plus 8 kp, okay, into dt. Yes or no? So you will get e to the power 1 plus 8 kp into t as integrating factor. Yes or no? You will get integrating factor as e to the power 1 plus 8 kp into t. I am erasing this part. Fine. Now you know very well. I am also using this diagram because our motive for this diagram is fulfilled, so we don't need it. Now you know how to find the overall solution. That is, what is dependent term IMT into integrating factor equal to whole integration of integrating factor into what is the term in the right side, 4 plus 96 kp into dt. Yes or no? Now IMT, what is integrating factor? E to the power 1 plus 8 kp into t equal to whole integration e to the power 1 plus 8 kp into t into 4 plus 96 kp into dt. Now solve it. Equal to, this is constant, it will come outside, okay. Now integration of this e to the power x is e to the power ax is e to the power ax by a, yes or no, plus constant c. This is the whole integration. Now fine, okay, take this part into the right side, so you will get IMT as 4 plus 96 kp upon 1 plus 8 kp, yes or no? This will get cancelled, this term and this term, plus c into e to the power minus 1 plus kp in 8 kp into t. Okay, so this is your solution for IMT. Yes or no? Now you know the initial conditions. How? You know at t equal to 0, what is the level of the tank? What is the level? What was the level of the tank at t equal to 0? 0 meters, and the corresponding current IMT was 4. Now at t equal to 0 seconds, HMT was 0 meters and current IMT was 4 milliampere. What was IMT? 4 milliampere. Yes or no? Let me check. 0, 0. Yeah, IMT was 4 milliampere. Now put these things. 4 equal to 4 plus 96 kp by 1 plus 8 kp plus c into t to the power 0, 1. So solve it for c. You will get 4 minus 4 plus 96 kp by 1 plus 8 kp. Solve it. 4 minus 4 cancelled. 32 minus 96 minus 64 kp by 1 plus 8 kp. This is value of c. Now put this c into the equation number 1. Consider this as equation number 1. Fine. Just so what we will get, IMT is 4 plus 96 kp by 1 plus 8 kp, and what is the value of C? Minus 64 kp by 1 plus 8 kp into e to the power minus 1 plus 8 kp. Yes or no? So this is your final expression for finding current IMT according to the level of the tank. Now we have found it. Okay, so let's check. Now we have one more term here. What is Kp? What value of Kp we should take here? So I am considering, let Kp equal to 1. Let Kp equal to 1. In that case, what will be the IMT? 100 upon 9 minus 64 upon 9 into e to the power minus 9t. Yes or no? Put Kp equal to 1 in the above expression. Fine. So I am considering different times. Okay. Let me erase the upper part. Fine. Now we will find at t equal to 0. We have time, HMT, IMT. Okay. Now at t equal to 0, what will be the HMT? HMT was 0. You know, initially tank was empty. What will be the IMT? Put t equal to 0 in this expression. So this will become 100 minus 64, 36. 36 by 4 is 9 is 4 milliampere. Was it the case? Look, we assume by that linear equation at t equal to 0, HMT was 0 and we found IMT was 4 milliampere. And by this solving this equation, you are also getting 4 milliampere. Now, at t equal to infinity, I am considering that tank is filled. Okay, that means I am equal to, I am equal to 1 meter. Okay, now put this t equal to infinity here. What you will get? 100 by 9. 100 by 9 means, what will be 100 by 9? It is sorry, it is in 1 minute. Yeah, so IMT is 100 by 9. Okay, 100 by 9 is how much? 11 point something, 11.11. Yes or no? In that case, if I am considering IM as 11.11, ideally it should be filled up to 1 meter. Now calculate by this formula. What is your HMT minus 0 by 2 equal to, what is your IMT? 100 by 9 minus 4 by 16. Calculate this using calculator. You will get some observations. (1.11) minus 4 divided by 16 into 2. Around, you are getting HMT around 0.88 meter. Okay, ideally at steady state we are considering it must reach to the set point, that is 1 meter, but it is not reaching up to 1 meter, it is reaching only up to 0.88 meter. That means there is still some error, and that error is known as error at steady state, which is equal to set point is 1 meter minus 0.88. Yes or no? So what is we'll get? We will get 0.11 meter. There is still some error of 0.11 meter. That means even why even by controlling the whole process we are not getting the set point, we are not getting the desired value, we are getting the error as 0.11 meter. Yes or no? So note it down till here. We will again go further for the remaining discussion. So till now we know at steady state we are also getting error. So our purpose is not resolved yet. So we need to do some more actions. Okay. So we have considered Kp equal to 1. Now do one thing. Take Kp equal to 10. Okay. Take Kp equal to 1. So if I take Kp equal to 10, for Kp equal to 10, my IMT will be 960 plus 4, 1000 by, sorry, this is okay, 960 plus 1000 by 81, okay, minus 640 by 81 e to the power minus 81t. Here exponential term was when k equal to 1 minus 90. When kp equal to 10, exponential term has e to the power minus 81. That means exponential term will decay very fast. Yes or no? This exponential term will decay very fast. That means your speed has been increased. As you increase the value of kp, your speed of the system has been increased. You are getting fast response. Yes or no? So kp is increasing. That means speed is increasing. Yes or no? So if we are getting so much, if we are getting such results, that means can we take kp equal to infinity? From this equation we are considering that as kp is increasing, our speed is increasing. So for ideally, if we keep kp equal to infinity, what are the various things? Okay, for that discussion I will take you into the flashback. Okay. First thing, we have to define the error band. Okay. So we know ICT is nothing but Kp into Et. So we know Kp is increasing, speed is increasing. So we must know what is the range or proper range of Kp. We can't predict anything 1, 10, 20. There must be some range. Okay. So what will be that range? Let's see. You know, ICT is varying from 4 milliampere to 20 milliampere. Yes or no? Now, what is ET? ET is 12 minus IM. Yes or no? ET is 12 minus IM. Okay, fine. And what is ET? What was ET? ET was IS minus IMT. Yes or no? So when tank level was 0, okay, so what was ET? What was ET in that case? When HMT was 0, we were getting IMT as 4. So IST is 12. 12 minus 4 equal to 8 milliampere. Yes or no? Now, when tank level is 1, when tank level is 1, what will be the error? Find it by the equation. 12 minus, when I am taking ideal case, when HMT is filled up to, we are taking maximum error band. Maximum error means the minimum level up to the maximum level of tank. Okay, so maximum level is 2. So from this, 2 by 2 is 1. 1 equal to IM minus 4 by 16. 16 plus 4, 20. equal to minus 8 milliampere. That means error band, maximum error band is from minus 8 milliampere to plus 8 milliampere. Okay, so your error band is this much. Okay, it all has some significance, that's why I am deriving all these things. Okay, now look, so error has been the proportional the band of error is minus 8 to plus 8. Now if I am considering only positive error, okay, so what is Kp by Et? Okay, ICT equal to Kp into Et. Now I am taking only positive part, so I can write Kp into 8. The minimum value of ICT is 4 milliampere, so that means Kp minimum is 4 by 8 equal to 0.5. This is the minimum value of Kp. Milliampere got cancelled. Okay, now what is the value of maximum value of ICT is 20. In that case, the Kp maximum will be 20 by 8, which is equal to 12.5. Okay, so our Kp range is 2.5 to 0.5 for positive errors. For positive errors, I have considered only positive part. Okay, note it down. And in case you consider negative, okay, in case you consider negative part, then you will get for Et equal to minus 8, you will get Kp range from minus 2.5 to minus 0.5. So if we want to write a common range that will cover whole values, then it will be from minus 2.5 to 0.5. Yes or no? It will be from minus 2.5 to 0.5. So if I take common, it will be from minus 2.5 to 2.5. So the common range will be minus 2.5 to 2.5. This is the range of Kp which we should take if the remaining parameters are these. Okay, so ideally you were talking that if we are increasing Kp, then system response is increasing. Okay, sorry, system speed of system is increasing. That does not mean that you should take k equal to infinity. There must be some region, there must be some range of Kp. So how you will define? By this. You know the controller current range, by according to the controller current range and maximum error band. So you have to find maximum error band. You know the controller output range, then you can easily find the range of Kp. What we did here. Okay. Now, so Kp must be having some range. So you found here with the help of these equations. Now, what happens if we are increasing Kp up to infinity? This is your input of controller is error and output is controller current. Okay. For proportional controller, we know ICT equal to Kp into Et. That means a linear relation between input and output. Okay, this is your slope. Okay, so we know there is proportional band. There is a proportional band, the maximum band of error. Okay. In case you may be familiar with this formula that Kp equal to 100 by proportional band. Yes or no? So if I take Kp in denominator, this will be the expression. So as Kp will increase, that proportional band will decrease. Yes or no? As Kp increase, proportional band will decrease. So now I am talking about the case Kp equal to infinity. If you keep Kp equal to infinity, your proportional band will become 0. Yes or no? That means this linearity will be vanished and the controller will be like this. And what is this controller? This is on-off controller. Yes or no? If you keep Kp at infinity, the proportional band will become 0. Yes or no? And the proportional controller will become as on-off controller. On-off controller. Okay. Fine. So we never prefer on-off controller. Why? Because there are only two conditions, two states. Yes or no? On, either on or off. In on, 100% open, valve will be 100% open. At off, valve will be 100% closed. So as the level in the tank is changing very rapidly, the valves will be rapidly closed or open. Okay. So in that case, if you are rapidly closing a valve or opening a valve, it may damage the valve. Okay. So for that reason, we never prefer on-off controller while measuring the level of the tank. While controlling the level in a tank, we never use on-off controller. So you got the reason why? Because on-off controller will close the valve, open the valve at a rapid pace. In that case, the valve may get damaged. So that's why we don't prefer on-off controller, and for that reason we can't keep Kp equal to infinity. Okay, because proportional controller will change into a on-off controller, which is not good for level control mechanism. Okay, so now one more thing. This is all happening till water reaches up to 1 meter. What if it goes beyond 1 meter? Okay, what if it goes beyond 1 meter? Very small discussion remaining. I hope all the things you got very clearly. Okay, so this was your figure. This was your Q0T. This was your QIT. I am saying this was your level up to which you have to maintain 1 meter, but your capacity is 2 meter. What happens if tank is filled up to 2 meter? Now HMT is 2 meter. In that case, what will be your IMT? IMT minus 4 by 16 equal to 2 by 2. Yes or no? So IMT is 20 milliampere. In that case, error will be, what your set point? Set point is 12 minus 20 minus 8 milliampere. That means the error generated is minus 8 milliampere. That means inverse action will take place. In that case, this valve will be opened and the excess liquid will be discharged through this valve. Okay, when the tank level will increase above the set point, the error will become negative. In that case, inverse action will happen and this outlet valve will be opened and the excess liquid in the tank will be discharged through this valve. As soon as the level in the liquid tank will come up to the set point or below the set point, again error will become positive. This valve get closed and again whatever we studied in the last 30 minutes, again it will happen. Okay, so once your level will be exceeding above set point, inverse action will be taking place. In that case, this valve will be get opened and the excess liquid will be discharged. Okay, so this was the whole procedure of controlling the liquid level in a tank. okay, with the help of proportional controller. So you got to know what was the whole procedure and why we are considering how we are considering a proportional controller, what are the various uncertainties, what are the various assumptions, what are the various limitations. We can't keep kp equal to infinity, although kp is beneficial for increasing the speed of the system, but still we can't keep kp equal to infinity because it will be giving proportional band as 0 and your proportional controller will be get converted into the on-off controller. In that case your valves will get damaged as they will be opening, there will be opening and shutting of the valve at very rapid pace. At some instant it will quickly open, at the next instant it has to close. So in that case you are not advised to use the on-off controller in the level of the tank. Okay, so this was the whole discussion about level control in the tank. Okay, so I hope you enjoyed it. Let's meet in the next lecture with some more interesting topics, and if you have some doubt, please keep that doubt in the comment section, and as soon as I get to know, I will respond. Okay, so I hope if you have any suggestions, please post it on the comment section, and I will try to improve the videos. Okay, and I will try to take many more interesting things into your notice. So okay, thank you for the time. Take care. Goodbye.